Let's look at a few examples of how we can use our unit circle to evaluate some inverse trig expressions. So I have 6 examples here. We want to evaluate each one if we can, if it exists. So our first example is we want to compute the inverse sine of the square root of 2 over 2. So one thing to remember is when we're computing inverse sines or inverse cosine, inverse tangent, we are always going to end up with an angle value. It could be in degrees, could be in radians. Let's do these in radians here. Kind of usually the default will be in radians. So since it's going to be an angle, sometimes or usually we're going to think of converting our inverse equation to being a non-inverse equation. So I really want to think about what angle makes sine equal to the square root of 2 over 2. So I'm going to rewrite my inverse sine of root 2 over 2 as sine of theta equals square root of 2 over 2. Okay, and so now I can apply what I know about the unit circle to this equation. For example, I know sine is positive in the first and the second quadrant. Okay, and so if I looked at that sine of theta is equal to square root of 2 over 2, that means I have to come up with a value in the first or the second quadrant. Okay, but I also have other restrictions. For example, the domain and range of inverse sine has been restricted, and so I know that when I compute inverse sine, I need to find an angle in the right half of the unit circle. So I need to find a value between a negative pi over 2 and a positive pi over 2. Okay, so the first quadrant from 0 to positive pi over 2, that would be where we have a positive sign. And then from negative pi over 2 to 0, the fourth quadrant, that would be if we had a negative sign. But again, in this case, we're trying to find where sine is equal to a positive root 2 over 2. I know that happens in the first quadrant, and that is an angle of pi over 4, right? So that means that because pi over 4 is between negative pi over 2 and positive pi over 2, and I know sine of pi over 4 is equal to square root of 2 over 2, I know the answer to the inverse sine of square root of 2 over 2 has to be a pi over 4. All right. The next part is number 2 here. We want to find the inverse sine of 2. So if I, again, try to convert that to a sine equation, so sine of theta is equal to 2. Okay. So again, think about the our domain and range restrictions. And so if we think about what angle makes sine equal 2, well, the range for sine is from -1 to 1, and 2 is not in that range. So if 2 is not in the range of sine, then it's not in the domain of inverse sine. Okay, so sine of inverse sine of 2, that 2 is not in the domain, so that means the inverse sine of 2 is undefined because it is not in the domain of the inverse sine, because it's not in the range of regular sine. All right, the next one, number 3, we want to find the inverse cosine of 1. And so again, I could think of this as the cosine of theta is equal to 1. So if we draw our unit circle, we think about our unit circle. For inverse cosine, we want the top half of the unit circle. And that's so that would be from 0 to pi for theta. And we want cosine to be a 1. And remember, cosine is the x-coordinate, so that would be the coordinate 1, 0 on the x-axis. And that corresponds to theta is equal to 0. And the domain, again, that we needed for inverse cosine was 0 to pi. 0 is included. So that means that the inverse cosine of 1 is going to equal 0. All right, the next one, number 4, inverse cosine of a negative square root of 3 over 2. So I could rewrite the inverse cosine of a negative square root of 3 over 2 as just the cosine of theta is equal to a negative square root of 3 over 2. Okay. Since it's a negative value, I know it has to be a number in the in the second or the third quadrants. And again, when we're talking about inverse cosine, we're restricted to the top half of the circle, so the first and the second quadrant. Cosine's positive in the first, negative in the second. So in order to find my answer for the inverse cosine, I need to find the angle in the second quadrant that makes cosine a negative root 3 over 2. And again, just from our unit circle, I know that cosine is a square root of 3 over 2 at a pi over 6. And in the second quadrant, that's going to be 5 pi over 6. So the inverse cosine of a negative root 3 over 2 is going to be 5 pi over 6. All right, number 5, we want to find the inverse tangent of 1. So we'll do the same thing. I'm going to rewrite this as the tangent of theta is equal to 1. And again, tangent's positive in the first and the third quadrant. But when we look at our restrictions for tangent, again, just like sine, we have to be in the first and fourth quadrant. So that's between negative pi over 2 and positive pi over 2. So I need the angle in the first quadrant since it's positive. And tangent is positive 1 at pi over 4. So the inverse tangent of 1 is going to be pi over 4. All right, last one here, number 6. We want to find the inverse tangent of a negative square root of 3. And so I'm going to rewrite that again as the tangent of theta. So flipping it around from inverse to regular, the tangent of theta is equal to a negative square root of 3. Okay, so what angle makes tangent equal to a negative square root of 3? Again, my restrictions, inverse tangent has to produce an angle in the fourth or the first quadrant between negative pi over 2 and a positive pi over 2. Tangent is negative in the fourth quadrant, so my answer has to be in the fourth quadrant, and it's going to be, think of it as being a clockwise rotation, so that we're between negative pi over 2 and positive pi over 2. So I know that tangent of theta would equal a square root of 3. Again, remember, tangent is the y over the x. So if my y coordinate was a square root of 3 over 2, and the x coordinate was a 1 over 2, the 2's cancel, and we're left with square root of 3 over 1, which is square root of 3. So what angle makes the y coordinate, or sine, a square root of 3 over 2, and the x coordinate, or cosine, a half? And so normally in the first quadrant, I'm just thinking positive right now. In the first quadrant, sine is a root 3 over 2, cosine is a half at pi over 6. And again, since I need this to be a negative square root of 3, we're going to just make it a negative 6. So the inverse tangent of the square root, the negative square root of 3 is going to be a negative pi over 6.